Hi, and welcome back to another physics or chemistry lesson with Mr. Simons. Again, atomic combinations and intermolecular forces. Last one I'm doing for today. So now we're looking at the June 2019 paper, question 2. And again, you can see same concepts, Lewis structure, polarity, dative covalent bond, etc. Consider the substances in the table below. Select the correct answer for each of the questions that follow. Write down only the letter that corresponds to the choice. So they gave me A, B, C, D, E there. HCN, magnesium chloride, iodine, ammonium ion, chlorine, water, carbon tetrachloride, carbon dioxide. That's what C2H2 and H2S. Alright, so they want us 2.1, identify two molecules that have triple bonds out of this list. Two substances then when mixed together will result in the ion dipole force of attraction. So ion 1 is charged particle, forms a dipole, separation of forces in the other one, they attract each other. A non-polar liquid at room temperature, a molecule having a tetrahedral shape, a solid that is insoluble in water, and a gas at room temperature with pure covalent bonds between its atoms. And so that's my first list of questions based on this table, right? Let's go to the second set of questions. Now they say compound F, H2O, and J, H2S are hydrates of group 6 elements. H2O has a lower molar mass than H2S, but a higher boiling point than H2S. Explain fully why H2O has a higher boiling point than H2S by referring to the types and strengths of the intermolecular forces in each and the energy involved. 2.3, draw the Lewis structure for compound G, CH4. 2.4, compound H, CO2 has polar covalent bonds in a molecule. Is the compound CO2 polar or non-polar? Explain fully. And then name the type of intermolecular forces found in the compound. Right, so let's answer it. So two molecules that have triple bonds. First one, HCN. Remember, hydrogen combines with one electron of carbon or valence electron of carbon, and there's still 3 left. So the 3 of carbon combines with 3 of nitrogen, so they form a triple bond. Same here, C2, H2. So A and I. Two substances, when mixed together, will result in an ion dipole force of attraction. So P and F. So if I take magnesium chlorine, I mix it with water, right? They will form an ion dipole force. Or T and F, if I take ammonia, and I mix it with water, hydrogen would leave there, that would form an ion dipole force. So either you have both of them correct and you get 2 marks, or one of the two is incorrect and you get 0. Non-polar liquid at room temperature. So a liquid that has no positive and negative side, it's non-polar. In this case is G, carbon tetrachloride. Right, so the polarity, if we take carbon in the middle, we have chlorine, 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 chlorine. Electronegativity is the same up and down and left and right, therefore it is non-polar. Carbon tetrachloride, also called chloroform, right, is a liquid at room temperature. A molecule having a tetrahedral shape, I've drawn it just now for you, the carbon tetrachloride. A solid that is insoluble in water, right? I2, remember I2 has dipole forces there. Iodine and water has hydrogen bonding, so the forces are not comparable, therefore they don't dissolve. It doesn't dissolve in water. It's not soluble in water. A gas at room temperature with pure covalent bonds between its atoms, chlorine, all right? Is a gas at room temperature. Now compound F, explain fully why H2O has a higher boiling point than that. Now number one, H2O has hydrogen bonding. Whenever we have oxygen bonded, then we know we have hydrogen bonding. There we have sulfur bonded. That is called a dipole-dipole force, right? So the intermolecular forces in the water, hydrogen bond is always the strongest. So hydrogen bond is stronger than dipole-dipole forces. Therefore, we need more energy to break the intermolecular forces in water than in H2S. All right, I hope that makes sense. So always test, do you know which one is hydrogen bonding, which one is London forces or van der Waal or dipole-dipole forces. We need to know hydrogen bonding is stronger than dipole-dipole forces. Right, draw the Leo structure for compound CH4. There's carbon and 4 hydrogens, which by now I assume you know how to draw. Right, and that would be 2 marks, one for correct amount of valence electrons, second mark, one for correct shape. Now 2.4, compound HCO2 has polar covalent bonds in a molecule. Is the compound CO2 polar or non-polar? Explain your fully. So CO2 is non-polar. It's a symmetrical molecule. So remember, carbon is in the middle and we have oxygen on either side, double bond, double bond. Right, so it's symmetrical, meaning my value to the right and the left are the same and they can subtract to give me 0 with even distribution of electrons, so the dipoles cancel out, therefore they are non-polar. Type of intermolecular forces found in the compound CO2, London forces, right? So I hope you understand. God bless. Bye. Next set of videos I'm going to look at boiling point, melting point, vapor pressure, etc. God bless. Bye.